Okay, so for the trig class here, I thought I'd do a little summary for worksheet 4.1b in terms of how to graph out secant, cosecant, and cotangent. So the big question usually comes up is asymptotes. Those are those lines that you see like this, and you can never cross them. So therefore something happens, something maybe like this, or like this, something of that form sometimes happens. So, but you cannot cross an asymptote. So the question is, how do you find them? So let's go back to what we've been working on all year long here. When we were asking you to find, say, sine of 0 degrees, cosine is 0 degrees, tangent is 0 degrees. So this would be 0, this would be 1, and this would be 0. Well, then the other half of this was, let's say, cosecant of 0, secant of 0, and cotangent of 0. So this here was D and E, this is 1, and this is D and E. Well, these D and E's are your asymptotes. And you actually only have to remember a couple of these, because when you have 0 degrees, that's the same thing as 180 degrees. So therefore, you also have asymptotes at 180 degrees. So that's where you have them for cosecant and cotangent. Now then the other half, so let's look at, let's say, sine of 90 degrees. Well, that's the same thing as 270, or negative 90 degrees for those three there. So if we go through and do it for 90 degrees, we'll also have for 270 and negative 90. So we have cosine of 90 degrees, tangent of 90 degrees. So this is 1, 0, D and E. Now the other ones, we have cosecant of 90, which would be 1. Secant of 90 is D and E. And cotangent of 90 is 0. So where are my asymptotes? So if I'm graphing out tangent, I'm going to have an asymptote at 90, negative 90, and 180. Like that. And likewise, the same thing for cosecant. So you basically, all you have to do is, before you start, do those two things for 90 and 0, and run through it, and you'll find which ones have asymptotes or not. So before you even start your let's say a test or your assignment, you got to graph these out, do those setups, and then that'll answer your question. All right, so let's graph out one here. So let's start off with, say, f of theta, and let's do negative 3 cosecant, and I'm going to go ahead and factor out the 2 theta minus 40 degrees minus 5. So the first thing you got to remember is we are going to graph out sine of 2 and theta minus 40 degrees minus 5, and basically flip it. Okay, so going through my parent graphs, okay, I'm going to graph out sine of theta, and realize there's a negative out here. Okay, so what does that graph look like? Okay. Alright, now I'm going to do a dotted line because I actually want to do cosecant, not sine. And this is negative, so remember I'm flipping it, so therefore it's going to go down. Like so. Okay. So there's my sine graph. Okay. Now, second thing, my amp, okay, is for sine is 3, but since we're doing cosecant, we're just going to refer to this as a scalar of 3. So what I have here is this is 3, negative 3, we got 0. So it's on an amp, well, it's referred to as a scalar. An amp is bounded between two values. And since we're going to flip it, it's not going to be bounded anymore. Now my values here, 0, 90, 180, 270, and 360. So the first thing we want to do here is look at this. So this is 2 times. So this is referred to as our speed, how fast something's going, how fast you're bouncing a ball, how fast the sun goes up or goes down. Anything that repeats itself. So if I double my speed, that's going to take half the amount of time. This x-axis is time. So I'm going to divide it by 2, divide by 2, divide by 2, divide by 2, divide by 2. So I have 0, 45, 90, 135, and 180. And what I have now, that's my period of time. So my period of time is 180 degrees. Now next week, when you actually be dealing with real numbers, that'll make a lot more sense. Okay, but right now, the period of time is 180. Okay, now the next part, if you look at your vertex, and this holds true just for all graphs, you have 40 and negative 5, but we have names for this. This is our phase shift of 40. So we're going to go through and add 40 degrees to each one of these. So I have 40, 85, 130, it's at 5, 7, 75, 0 to 220. Okay, and take a note that you still have the same amount of distance here, period of time. So if I take 220 and minus 40, okay, that is still 180 degrees, which is still the same amount of period of time. It's just a matter of when you start. So think of around a racetrack. So instead of starting here, let's say that's the starting line, you're going to start back here. Or you might start over here. Is this a different starting spot? But still, you got to go around the track the same amount of time it takes you. You're just starting someplace different. Okay. Now the last piece here. Let's see here. Let's see with this one here. Your vertical shift. So for each of those values, we're just going to add negative 5 to it. So if I add a negative 5, oops, that's supposed to be negative 5. That would be negative 2, negative 5, and this would be negative 8. Okay. Now we're ready to do cosecant. Now remember that when we came up here at 180 and 0 and 360, so if I slide back up here and look at cosecant, okay, notice at 0 and 180 it does not exist. Okay, that's where I should have an asymptote. So if you look at that, here's 0, here's 180, and 360, right where it crosses. So therefore, here is my asymptote. And let's see if I can find a color I haven't used yet. Let's go pink here. And therefore, if I flip the graph, there it is. Okay? So that's how you're tying everything in together. All right, so let's look at one more. Let's look at, let's say f of theta equals 5 cotangent of 3 theta minus 20 degrees minus 8. Okay, all right, so first off, my parent graph y equals cotangent of theta. So where do I put my asymptotes? Okay, so here's my graph. And let's put in, let's say negative 90, 0, 90, 180, 270, and 360. Okay, well, I'm going to scroll back up and let's look at cotangent. Okay, here's a cotangent here. So at 90 degrees, which is the same thing as negative 90 and 180, it's defined there. It doesn't exist at these two values. Okay. Oops, excuse me, I think that should have been 270, by the way. My bad. Okay, I had it up there. So here's my asymptotes, 0 and 180. There's my asymptotes. All right, so let's go down there and let's put them in. That's 0, 180, and 360. And draw it out. Now, everything right now, this is a positive f of theta, so because there's a positive there, which means here's quadrant 1. From 0 to 90 is quadrant 1. So therefore, I always kind of think of these things kind of look like y equals x cubed graph. They're like this, or like this. They look like a cube graph. Okay? And there is the graph. Okay, so now all we have to do is change our values. So 2, we don't have an amp, we have a scalar of 5, which doesn't change my sketch. Okay, my period of time, well, now here's one thing here. So if I go ahead and this is times 3, I'm going to divide by 3, divide by 3, divide by 3. After that, I'm just repeating myself, so it's going to happen much quicker. So I have 0, 30, 60. So how much time does that take? 60 degrees is the period of time. I could do another keep going here, but it's the same graph. So the period of time is 60. Now my vertex is 20, negative 8. So there is my phase shift. So let's go ahead and add 20 to each one of these values. So I have 20, 50, and 80. And notice that same distance is still 60 units. Okay, and then the last thing is my vertical shift. And basically, that's, let's get rid of that. This is 0, so all I have to do is just change that to negative 8. That's the only one I got to change on that. The other thing too, I guess I should have talked about domain and range on the other graph. Let's talk about this one. So my domain here, I have asymptotes. So I say all rails except where my very first asymptote is located. I can pick any one of these, but let's pick the one that's closest. I'm going to say 20. That's that asymptote there. And then plus and minus, how far does it take to get to the next asymptote? Well, it takes 60 degrees to get the next one, so it's 60 in. And therefore my range, now there's no restriction, so it goes up and down, so my range is all rails. And there's cotangent. All right, so now I'm going to go back, since I forgot to do domain and range on the other one. So let's come back here. And let's talk about domain and range on this one. So I have all rails except, and the reason I have to say except because I have asymptotes here. All right, so let's use black here. So where's my very first asymptote? Yeah, it's right here. It's 40 degrees. Now, how far is it to the next asymptote? Well, from 40 to, I can't read it. What is it? Well, that's 130. How far apart is 40 and 130? Well, that's 90 degrees. So therefore, it'd be 90 in. And then the next one is 90 degrees. My range values, okay, I have to look here, see it goes down. So it'll be y is less than or equal to -8. That's this value here. And y greater than or equal to, looks like -2. And there's my domain and range. Okay, so hopefully that helps out a little bit on the graphing part of it. Just one other thing I want to go over in terms of going the other direction when you have to write the equation. So let's say you have to write the equation, and if I give you, let's say f of theta is cosecant of theta, and there is a negative f of theta, and I think the order is going to be probably different here, or this could be down here. I'm not sure where I put it on the assignment. Let's say there's a scalar of 7. The period of time is 40. 5 phase shift is, let's say, 10. And 6, let's say the vertical shift is -7. So first off, that's your vertex, 10, -7. Now the only thing you have to do here is this piece here. No matter what, for cosecant, secant, cosine, and sine, you always just take 360 and divide it by 40. And in this case here, zeros cancel, you get 9. So that's how fast things are changing. So write this equation, f of theta. My scalar is 7 with a negative in front. Cosecant, how fast is things changing? 9. Put my vertex in, so theta minus 10 and then -7. Okay, so let's do one more with cotangent. So let's say you have f of theta, so my parent graph is cotangent of theta. 2, we'll throw a negative in front. Let's say my scalar is 7, and my period of time is 40. 5, phase shift is 10, and say my vertical shift is -7. So again, remember that is your vertex, 10, -7. Now the only thing you have to worry about this is for a cotangent and tangent, the period of time happens at 180, much faster. So therefore you always divide it into 40 on those two graphs. So therefore, what do we have here? 9/2 reduces. So that's your how fast things are traveling or changing. So let's go ahead and write the equation. So f of theta. So my scalar is 7 with a negative in front. My parent graph is cotangent. How fast things are going, 9/2. Do my vertex, theta minus 10, -7, and there's my equation. All right, so hopefully that helped out a little bit to finish your assignment and get that turned in.